My name is Jane Peck, and I'm with Redis Labs. I manage the solutions architect team at Redis in the West. And our team works with multiple different customers around very interesting use cases. And we get some interesting insights as to how do customers do things? What are the right design patterns? What are the things you should be aware of? And the thing that keeps on coming up with a lot of our customers as they become more sophisticated with how they use Redis is protecting your APIs. Right? And they want to know how to use Redis as a rate limiter. And on the flip side, how do you use Redis for metering purposes? Okay? So the agenda for today is to go through kind of higher level concept for where people use metering and rate limiting as a kind of a high level view, some of the design concepts that you should be aware of, and why specifically Redis for rate limiting and metering. And then we'll get into some, patterns, anti-patterns, some design considerations, and I have a demo that one of the members of my team created. Hopefully it's relatable because it's around beer, and it's a rate limiting demo, and then we'll get into some resources that are available. So my goal for this 20-minute session, I think I have 20 minutes, is one, to give you almost like a touch point on, I didn't realize Redis could do that. And those are the different dials that I could use to determine which pattern I should use, and what are the data structures that I may want to consider, and what are the controls within Redis that allow me to do this, right? So it is still high level. The other aspect is to really pimp the webinar that another member of my team is going to do, and he's very, very technical. And so he's going to do a webinar on January 16th at 9 a.m. Pacific, getting more deeper into the specific use cases, even getting down into code examples that he shares with our customers on how do you do certain types of rate limiting within Redis. Okay? And then the last thing is, under the resources, I show it here, but you'll also see it on my last slide, is Redis University, where you could take free online classes to really understand basics of Redis. Redis 101 includes rate limiting, example exercises, and other use cases within Redis. Okay? All right, so let's get started. Metering. It's everywhere. We all touch it. We live and breathe it every day. I got limited by Google with my G Drive content, so now I have to pay Google because I've exceeded my 15 gig limit. And it is like everywhere and everything that we do, especially in the electronic world. So I typically break apart metering into two different segments. One is focused on metering from the view of revenue growth, and the other aspect is risk mitigation. How do you block something, or block people or services to prevent them from using too much of your resources? Okay? So as you think about your business and how you interact with your services that you consume or services that you're providing for your customers, very high probability you are looking at a mechanism of metering someone to determine whether you need to have a pay-as-you-go system. It's free for now, but how do we make you pay for it? Tiered pricing for this bundle of services is great, but you may want to add, Spotify? If I want to add 4 more users, I have to pay the next premium dollar, right? So all those things require mechanism of metering and tracking uses from a window of time, and tracking uses from a revenue standpoint. On the flip side, there's risk mitigation, right? Traffic shaping, security, rate limiting. I have a friend who loves to pull financial data out of Yahoo Finance. Yahoo Finance limits you on how many stock pricing you could pull on any given time window, right? And so Twitter does a lot of rate limiting, a ton of stuff that you touch day to day, DDoS attacks, everything else. You want to put some limitations around what people do with your API. And I suspect, how many of you guys are developing APIs or use APIs in your environment? Right, vast number of you. At some point, you'll realize, people are not using this the way I thought they should, right? And I hear that all the time. So risk mitigation is another big reason why people use Redis as a rate limiter. So what are the rate limiting casualties? And a lot of people define them from a bad actor standpoint, but there's also a lot of unanticipated use cases. I've had one retailer who created an API gateway, and they're like, why are they calling my API 100 times a second? Like, that was not what they were supposed to do. We thought they would call it once every minute, right? So all those scenarios or programmatic errors that all of a sudden from one rev to another, the calls into your API just 10x, right, or 1,000x. So for all those scenarios where it's not intentional, those calls into the load balancer and branching out into your APIs, even if it's one particular service, will then have more calls into the back-end system, like a MySQL database. That then goes kaboom, and then it has like forward ramifications, and soon you're talking about very upset consumers and potentially money going down the drain because your entire service stack has gone down. So what do you need to meter and rate limit? Right? If you're already thinking, all right, Jane, you've sold me on the fact that I need to rate something, I need to limit something, how do I think about the process of metering or rate limiting? And one of the hardest parts, and you'd be surprised, is the who. Who do you identify as the unit to limit by? And in a lot of these security aspects, you could say, well, maybe it's an IP address, right? But if you just limit on IP addresses, actually, the flip side I was going to give the example of is sometimes if you just use IP address, especially for metering and resource consumption, is that one big major customer could be representing 10,000 consumers. So by limiting that one little IP address, you don't get granularity into every single user who actually came into your system. Okay? So identifying the who, determining what is the right mechanism of identifying them, and determining also whether it's business relevant. Because the trade-off is the more narrow you become, the more resources you consume, right? And there's also some kind of time or latency overhead that you need to include because you have to have more granular control over who's limiting it, all right? So the other aspect is how. What pattern to use for rate limiting? And so there's different concepts, different data structures, and we'll go over some of the really simple design patterns around rate limiting, and there's lots of different options available. And the great thing is if you search rate limiting Redis on Google, there's many different code examples that talk about lessons learned about things that they have done successfully and unsuccessfully, okay? And finally, so you have the how to identify the person, and then figure out what you need to do, but also where to store it. And one of the key things to think about from an API or metering concept is speed, right? The longer it takes for you to process that one transaction to authorize that request or not, there's potential revenue impact and also potential like system impact in terms of how much time you take, right? So that's where the fast centralized data store is useful, hence Redis comes into play. Okay, so why specifically Redis for metering and rate limiting, right? Sometimes you don't know the volume of transactions that are going to come through. You anticipate at a certain rate, but you just don't know. And one of the things that Redis is very good for, obviously you're here, is because Redis is extremely performant, so it's very, very fast in processing these queries. Okay? It's a fast centralized store, optimized commands to control the resources, and I'll go a little bit deeper into what those are. But for example, incrs, deckers, counts, I think a lot of the sessions I covered some of the probabilistic data structures that talk about cardinality. How do I identify the number of entries in my sorted set? How do I identify the number of entries in my list? Or even, just a get on a string, which actually is a counter. So there's many different ways in terms of counting things in Redis, and that becomes an interesting design factor that you should take into consideration. In database analytics, and this applies more on the metering side to understand how many users, at what window of time, who are my top users, my most abusive users. All those things are useful to capture in a leaderboard. So as you think about rate limiting and metering, some of the tangential statistics that you want to gather on who's doing what most frequently, and should you take certain actions against them, with them, for them, there's a lot of built-in analytics tied to how Redis functions. Okay? And obviously flexible data structures. I tell people Redis is an extension of the developer's tool set. Okay? So a lot of the data structures that you use or could access in Redis are really part of the traditional programmatic code where you could say, oh, I want a string, or I want a hash, or I want a set, or I want a list, and so on. Right? So it's very easy and familiar for developers to think about using these data structures within Redis. So some of you who've attended previous Redis sessions, you'll recognize this particular slide that describes all the different data structures within Redis. And these are built-in data structures directly in Redis. Okay? So the ones that I've highlighted, I'm sure our marketing team is not seeing this because I violated the color code, is that there's a couple of components which gets referenced all the time within the rate limiting concept, like strings. And strings for Redis, in terms of rate limiting, is applicable more from a counter standpoint. You could do incurs and decurs just on a string. And I think Madeline earlier talked about dynamic typecasting for Redis strings, where depending on if you set a key name to a string, and then if you try to do an incur, it'll say, hey, this is not a number, right? So strings, hashes, how many of you are familiar with hashes? Great, thank you. Lists, just kind of a queuing, pop, push kind of concept. Sorted sets and hyperlog logs. These are the typical components within Redis that you could use as part of your rate limiting design pattern. My favorite data structure, by the way, is hyperlog log, but you could have a side conversation with me afterwards about that. All right, so let's talk about the specific Redis commands for metering and rate limiting. I've broken them up into different functions, okay? So the concept of incurring and decuring, the reason why it's so useful is that, one, it's super fast, and it's applicable, say, at a string where incur key or incur by an increment, or you could apply it at the hash level with h incur by. For any specific field within a hash key, you could do that. Or z incur by, where you could incur a particular score for a member of a sorted set. Okay? So those are the different incur commands. And on the decur side, it's not quite mirrored, but you could decur of a key or a decur by, and those two will apply to a string. In terms of counting, and this is what's really cool about Redis, depending on which data structure you use, a lot of these data structures allow you to identify the cardinality or the elements inside that data structure. So list is ln, set is scard, sorted set is zcard, hash is hlen, hyperlog is pfcount, and bitmap is bitcount. So that gives you options on, depending on what your design pattern is, this gives you a list of how do I count the elements within it, because that's then going to determine how you limit something, okay? And then the last one is setting the expiry, right? Expire by a key by the number of seconds. And when you create a string, you could actually set the creation of the string based on its existence, and also define an expiry all within the same command. Right? The other nice thing is that you could specify it at the millisecond level. So if you want to have super granular control over the life of a particular key or life of a resource, you could do that within Redis. Okay? And then the last thing is if you've set a lifetime of something, you'd want to know what the lifetime is that you have remaining. Hence, you'll get the TTL and the PTTL commands. So now that you have this broader tool set of choices of data structures, ways to count, ways to incur, what are some of the things that you should think of or keep in mind as you look at designing a rate limiter, right? So the key thing is defining the time window. And it sounds simple enough. Well, I just want to have 10 requests every second, right? But sometimes you almost have to consider a rolling time window of, do you want every second, but do you want to have a more spread out window for that minute and then spread it out even further? So when you're looking at time for the perspective of time, don't just be narrow-minded about that one particular usage pattern. Think of the broader perspective of what information do you want to limit and how you want to spread that call over time. Okay? Notice that users can be humans or services. So be conscious of identifying who is going to consume the data. And I mentioned it earlier before, but identifying the user and having a key space mapping. I think one of the other speakers really talked, I think it was Scott, that really talked about how do you make it really clear how you define the key, right? That in itself is going to pay you dividends if you think far in advance of kind of the ramifications of designing your key in one way to be very specific, or another way which is very generic, okay? There is trade-offs around complexity. I think some of the things that I started adding on adds to the complexity. That also could potentially add to latency. And it also has ramifications in terms of data usage, determining what type of data structure and the granularity of the key could either increase your memory footprint or be very, very narrow and small. And then one size doesn't fit all, right? So figure out and go and study different options available, and you could also grow into it to have like a simple use case and then slowly build it out over time, okay? The one thing is consider over-limit behavior, and I was trying to explain to someone, like, what does that mean, right? And that basically means if somebody violated your limit, what do you want to do, right? Do you want to like, just block them off? Or do you want to give them a little bit of a buffer? Or do you want to give them a warning but let them do it? So there's a lot of subtleties into what you want to do when that limit is exceeded or hit, okay? So we'll be examining rate limiters from a distributed concept. You as programmers, you could write rate limiters and just run it within your particular service. But often, especially in the microservices world, you have multiple services that are all trying to do the same thing, or you want the flexibility to be able to scale up and scale down. And in those types of environments, you don't want the control to be on the service side. You want the data-related component to be on a separate database. Okay? So simple fixed window counter. So this is probably the most simple, basic way of doing a rate limiter in Redis. Okay? Define number of requests per time interval. So you could say, I want 5 requests per minute, per second. You have to pick, you kind of have to identify your window, fixed window, and then for that fixed window, how many requests are you going to allow in? In terms of identifying the user, we chose a user, and it's a fixed user, :identifier, and then a start time. And in this example, we have a user, IP address, and a start timestamp. And this specific one, obviously user : so this is saying this is a user key. The IP address of the user is 127 ... And then here is my Unix timestamp. Okay? And then we're going to use some really basic commands of set or setex for the existence, incurs, and TTLs to really enforce this particular kind of rate limiter. And we'll also use or rely on Redis to handle all the expiry. So that's a great thing. You don't have to worry about, should I expire it or not, right? Redis handles the expiry. So the workflow is, user makes a request to the API, kind of goes to a decision tree. Does a user's key exist in the current window of time? No. Create the key. Yes. Increment the key. Is the key value over the limit? Yes, no. Allow or deny. Really simple, right? So just from a visual cue, and one thing that I want to keep in mind, my fixed window is not a shifting fixed window. It is locked to that minute, the start of that minute to the end of that minute, okay, in this particular example. So here, at 20 seconds in, I might almost like time 0, and then 20 seconds in, I made 2 requests. The command that I issue is setex user 1, right, time 0. I have 40 seconds left of my 1-minute window, so I set the expiry to 40 seconds, and the number of requests that came in is 2, right? So notice that the key is user : 1 : 0. 0 represents a time window, and the value is 2, the TTL is 40. And at the end of that minute, by the way, should we approve this? Yeah, 5 requests per minute, you're allowed, so off you go. And then the next one, the next window of time, is that, at 1:05, I set the 2 incurs, and then at 1:30, I had 3 more requests. That is also approved because it's equal to 5. And at 1:50, they try to do it again, right? Violation, so we say no. And then at 2 minutes, Redis automatically expires the key, right? You didn't have to do anything bad. And notice the simplicity. Notice the number of Redis commands that I had to issue, right? Really, really elegant, except it has its own issues, right? So in this example, notice my minute 2, my 3rd minute, right? Notice what happens in terms of the entry point of my request. So my request is coming in at 2:15. I have 4 requests coming through. But if I were to look at the impact on my system, within this 1:30 to 2:15 window, I've actually allowed how many? Close to 12, 16 requests coming through in that window of time. Am I doing my math right? Right? So if you were to look at your resource and say, I'm only allowed to give 5 per minute, but I'm now exceeding my limit because the users could jump between time windows. And so you could have a lot of requests kind of pushed to the end of one time window, and then jump over to the next window, and a lot of requests could come in at the front. So that's where some of the bursty behavior comes in, and there's ways to design in such that you spread out those calls over kind of a much more smoother profile on how it accesses the resources. Okay? All right. So if I don't want that bursty behavior, you may want to consider more of a sliding window, right? So rather than being tied to I have 4 minutes left. Okay, so rather than being tied to certain fixed window, minute 1, minute 2, minute 3, I want to be able to shift my window so that at any one point in time, the window is always moving, and then you'll have, approved. So here are my expired requests in my sliding window. I have, 10 requests per 60 seconds, assuming these are 10. So these ones are rejected because they exceed here's my first 10. And so these two, within my 60-second window, they're no good. The next sliding window, this one's okay because I'm within my 10. And then, the last 2 are allowed, but then the third one is rejected because it's violating my 10 count. Okay? So sliding windows use sorted sets. Every request comes in saved as the score. Actually, you could even store the score as well as the name as a sorted set. And then you'll have this concept of adding, counting, allow, not allow, also remove, right? So the usage of a sorted set, you have to constantly trim the sorted set such that you don't get massive memory bloat. And even then, this is potentially, it could get expensive if you have a massive influx coming in. And you could still deny a bunch, but in that window of time, you could be retaining quite a number of entries of requests that have been made into the sorted set. Okay? So the other one that I wanted to cover was the token bucket, which you could use a hash. I'll make this available online. These slides are available so you could take a look at it. Token bucket is a little bit simpler of a use case. The actual memory footprint is quite small as well. The biggest cost to a token bucket is related to race conditions. So there's a whole get set option. And if you get something and you're doing manipulation and you do a set, in that period of time, if another service tried to do the same thing, you may actually have a conflict, right? So you could consider using Lua or a multi-exec with a watch option, like optimistic locking, in ways to kind of constrain that particular problem. Okay? So I think I talked a lot about the different anti-patterns. Right? Be a little bit more sophisticated than you think is necessary in terms of how you design your rate limiter. Like we talked about the token bucket. Think about your total goal for the round trip time for an API call. I've had some people say an API call where this particular rate limiter piece should not be more than 10% of your actual round trip latency time. So take that into consideration. One person told me 20, some other people told me 10. Be as conservative as you can and tighten up the actual latency time. Unclear user identification, right? That in itself is really interesting on how you do metering as well as identifying the user, okay? So I do want to show you a quick demo. This is a Node.js, and we thought, okay, you know what? We're going to create a fixed window drink limiting demo. And in this, where we have Dallas, who loves beer, and we have Kurt, who is like the gatekeeper. Here's a bartender that says you are only limited to 10 drinks per minute, right? So you could order a drink, and the response is, yay, you got a drink. And then notice what's happening here. On the Redis side, I have 1 drink count. Remaining time in the window is 9. I'm going to order another one. Everything's good. But now I hit my 11. I only have my time window is tricking down. And so the remaining time at the end of that window, the key basically got expired from Redis, right? So that's why you get a -2 because the key no longer exists, okay? And I'll actually show you the Redis details. I'll order another drink now. New window, I could continue to order, and the time trickles down. And as I start adding more, so notice you could see the drink counts incrementing as I continue to drink the really big, jug of beer. But Redis prevents it from happening, and you're still going to get the 529. You have exceeded your limit. Okay? Great. So from a resource standpoint, I have 23 seconds left. I'm almost there. So from a resource standpoint, webinar, please check it out. You'll get a lot more details than what I covered today on different strategies around rate limiting. Redis University, there's some great articles available that goes in with a lot more code examples on how you do rate limiting. And then we have GitHub options for Java as well as Python. And you could always reach out to my team about, what is a right way to think about rate limiting in Redis. Okay? Thank you.